Hello, I'm Adam, and welcome to my tutorial on exponential functions. Yay! Okay, so before we dive into our exponential functions, we need to do some practice problems from Algebra 2. So our first example, it's an example that most people should be able to do, but it's good practice. It says if f of x equals 1/3 to the x, find, and then we have a, b, c, d. So it's fairly simple. Whatever is in the parentheses in example A, it's 3, goes in place of x in the problem. So for A, it would be 1/3 to the third power. So basically, whenever there's a fraction and it's to any power, you do it for all the numbers. So you do 1 to the third over 3 to the third, which equals, yes, you guessed it, 1 over 27. So that's our first one. Example B says it's f of -3. So you do the same process of 1 over 3 to the -3, but since there is a negative, you must flip the fraction. So if it was just normal 3, you would have to flip it and make it a fraction. In this case, you flip it, put 1 on bottom and 3 on top. And since it's 3 over 1, that's just the same as 3, so it's 3 to the third, which equals 27. So that's fairly simple so far. So now we have f of 1/2. So first, for f of 1/2, you do the same thing as you did for the other one. So 1 over 3 to the 1/2. So this is more of it's a square root rather than squared. So basically it's the same as this one up here. You have to do it to both of the numbers. So it'd be square root of 1 over square root of 3. And since there's an imaginary 2 there. Okay, and then you do, and since square root of 1 is 1, over the square root of 3. But to make it rational, you have to multiply it by another form of 1, which is square root of 3 over square root of 3, which equals square root of 3 over 3. Our final example, D, is f of 0. So same process, 1/3 to the 0 power, and anything equal to 0 is 1. So those are your 4 answers. So now let's move on to graphing the parent function. Now we're moving on to some big boy stuff. Graphing. Okay, so for graphing, we always need to make a t-chart so that we know where all our points go. So for x, we're going to just use -1, 0, and 1. Oh my gosh. And 1. Okay, so in this we have b in our y. So basically you plug -1, or in coming down to these, we'll come down to these. Starting with -1, you plug -1 into where x is. So it's b to the -1, which equals 1 over b. Next is 0, and we did this during our practice problem. Anything to the 0 equals 1. And then we have b to the 1, and that is simply b. So now you have your points. Since this is the parent function, each is representing something, so now let's move on to graph. So we have -1, 0, and 1 for our x, and we have y is 1 over b, 1, and b. So 1 is going to be, so first we have -1 and 1 over b. So it would be -1, comma, 1 over b. And that's your coordinate. So it's right about here on your graph. And then we have 0, 1. And that is 0, and then go up 1. And then we have 1, comma, b. So 0, comma, 1, and then we have 1, comma, b, which is right about here. So we have our graph. That is, oof. Let's try that again. Make that a little better. Okay, now we're on example 3. So example 3 says graph 3 to the x. So first we need our x coordinates, which could be really anything, but to make it easier on ourselves, we'll do -1, 0, and oh my gosh, and 1. So now you use the x coordinate and you plug it in to where x is. So in this case it would be 3 to the -1, which equals 1 over 3. See, we're just basically doing what we did in example 1. So now we do the same thing for each x coordinate. We have 3 to the 0, which equals 1. And then we have 3 to the 1, which equals 3. So now we graph. So we have -1 and 1/3. So that's roughly about there. Then we have 0, 1, and 1, 3. 1, 2, 1, 2, 3. And then we draw our curve. Mine isn't very pretty, but you understand. Okay, so we finally made it to example 5. So this says 3 to the x plus 2. Pretty much the same thing, but very different. So we have, this is, because couldn't figure out how to type it, it is 3 to the x and then plus 2. Plus 2 is separate from x. So, basically the same thing, but this plus 2 right here now becomes a vertical shift. So we have vertical shift. And we'll see that represented in our graph. Okay, so nothing changes. We have 3 to the -1. See that? Which equals 1 over 3. Next we have 3 to the 0, which equals, oh, not 0. It equals 1. And then we have 3 to the 1, which equals 3. So, same thing, except we have to add 2 to the y-intercepts. Plus 2, plus 2, plus 2. Because it is a vertical shift. So, we have 2 and 1/3, 3 and 5. So, we go over to -1, go over -1, 1, 2, and then barely above 2. Next one is 0, 3, so we have 1, 2, 3. And then we have 1, 5. So 1, 2, 3, 4, 5. Basically, the same graph, just moved up. So, we have our graph. Mine are not very pretty, but it's okay. Okay, so now we're on example 6. We're almost there. I know I'd be mad at me too if I had 7 examples in a lesson, but that's just how it goes. So now we have graph f of x equals e to the x. So e is just any ordinary number, basically. It's kind of like pi. It just has its special little symbol. And so we do the exact same thing we've been doing for this whole time. So we have e to the negative 1, which equals 1 over e, which is equivalent to 0.37. Next we have e to the 0, which is of course 1. And finally we have e to the 1, which is 2.7. Trust me, you can look it up in your calculator. It's the same thing. So now we need to graph. This is the easy part. So now we have negative 1.37, kind of like 0.3 that we've been doing, right about there. Then we have 0, 1, and then we have 1 and 2.7. So 1, 2, and then kind of close to the top. So then we draw a line, and there you go. Pretty much looks like any other graph. So we're finally there. We're finally at example 7, the final example. But this is a little different concept. So this is determining a formula given the x and f of x or y coordinates. So basically you have your basic coordinates in the x, negative 2, negative 1, 0, 1, 2. And then you have these coordinates right here. So now you need to, first thing first, is to find the number that is common in all of these numbers right here in f of x. So a number that is common is 6. These are all divisible by 6. So we have 6 times 1 over 12, 6 times 1 over 4, 6 times 1, 6 times 4, and 6 times 12. Okay, so now we do the exact same thing, just with the numbers we have left, not the 6's. So we have 1/12, 1/4, 1/4, and 12. So one number that goes into all these numbers, besides 1, is 4. So we have 4 in this one. We have 4 and 12, so which is 1 over 3. 4 in this one, which is just 1. 1, 4. They all have 4 in common. So basically you have 6 and 4. So now you put them in the formula. So now you have your numbers right here, and you just plug them in. So basically your first number, 6. Okay, so you have your first number 6, and that goes in the front. So we have y equals 6. Now you have to use your 4. So now comes into your play your, so this is just multiplying because you're multiplying everything. And then it's 6 times 4 to the x. And that is your formula. Right there. Okay, so now we have covered a lot in this lesson. We've covered how to graph the parent function, how to graph different exponential functions, how to graph with a stretch, how to graph with a vertical shift, how to graph with e, and how to determine the formula. A lot of stuff going on. But it'll all come together, and you'll be glad that you know how to do it.